Okay, so let's just jump over to D2L real fast and check out what the expectations and the goals are for this week. Yeah, Demetrius, what you got? Yeah, go ahead. Don't need to ask, just jump up. All right, so this week, what we're going to be doing is that, believe it or not, you guys are going to make your first full-blown 3D model starting today. As you can see from the assignment sheet on D2L, your goal this week is to make a train. Yeah. You're going to be making, specifically, that train right there. That's our goals. Now, don't freak out. I know this is our first true three-dimensional model, but it's okay. Don't freak out. You guys can do this. I know you can do this. I wouldn't give you a task that I didn't think I knew you guys would be able to knock out of the park, okay? At the end of our conversation today, you'll be equipped with all the major ideas and formulas, if you will, to be able to construct a very simple train. I need you guys to play along, though. I'm going to ask you guys to return to kindergarten. I love kindergarten. I wish life was kindergarten. I really do. It's fantastic, right? But in kindergarten, you learn some very important spatial kind of reasoning skills. You worked with building blocks, right? Legos. How many guys used to play with Legos? I still play with Legos, okay? I'm very happy that my son's 2 and now he's playing with Legos because now I have a real-world legitimate reason to play with Legos once again, right? I love playing with Legos. We're going to return to that mindset. Because if you think about it, Legos are nothing more than a whole series of very simple, basic building blocks. From these very primitive shapes, we're able to create really amazing structures, from characters to castles, spaceships, and trains, right? From simple beginnings, we get very complex results. That's what today's conversation is going to revolve around, okay? We're going to start working and creating basic primitive shapes, basic series of shapes, cubes, cylinders, spheres, donuts, things like that. From that whole kind of exploration, we'll be able to start making something that's a little bit more complex. So don't worry about the details of the train, okay? You're going to be able to do this. We're also going to start talking about how we can incorporate reference images into our pipeline. That's going to be a big component of what we do in the 3D modeling business, in our industry. So we'll talk a little bit about that as well. By the end of this week, you'll be able to make this very train. Every one of you guys are going to be making this train. And so it's going to be a pretty exciting adventure over the next 7 days as we begin to flush this out. This is going to be your first kind of big project, if you will. So I want you to make sure you temper your own expectations. You are not making an incredibly high-res, high-detailed train. You're making this, okay? It may or may not look like a train, but that's okay, all right? The first time out, everyone falls. The first time out, it never looks the way it's really supposed to look. I remember when I first started doing 3D modeling, I remember vividly I was trying to make an airplane, right? And in my mind, what I saw on the screen was an airplane. But to I think my older brother, he was like, that doesn't look anything like an airplane, right? But my imagination made it into an airplane. It wasn't a really great model, but the basic building blocks and the shapes that I created on the screen was enough for me to kind of suspend disbelief and believe that it was an airplane. You guys are going to be doing the same thing, okay? Basic building blocks will allow us to create complex shapes later on. All 3D modelers begin with an initial rough out pass. Believe it or not, we don't model things incredibly high resolution initially. We almost have to begin our process similar to the way a traditional sculptor would begin theirs, right? Imagine, if you will, you're sitting in front of a gigantic, piece of granite or marble, okay? You're not going to start, carving out the details of an eyebrow or the wrinkles first, right? You're going to start to work in passes. You're very easily going to start to establish the overall shape, establish the overall volume, find the planes that define the certain characteristics of the overall shape first, and then once we're happy with the size, scale, and proportion of all these different elements, then we can go in and create an incredibly high-resolution object that does look like a real-world analog. You're going to start here, and then later on in the semester, once we have a couple more of these projects under our belt, you're going to take the project that you began with today and up-res it and add detail and start to produce a level of detail within our geometry that makes it look a little bit more real.
Will we UV map it?
No. Unfortunately not. UV mapping is not something that we really have the time or the capacity to really dig in 402. UV mapping is like 424. Like if you were here at 1 o'clock, I spent 4 hours talking about UV mapping today. So we'll cover that in detail in another course. All right. Questions, questions, questions. We're going to come back to the details of our homework towards the end of class today, so this isn't the last time you're going to see this assignment sheet. Just as a small reminder, with all the projects that we do, I'm going to try to give you guys as many visual examples to what I'm expecting you to build as possible. The examples that I've given you in the small pictures down below kind of illustrates the importance of this true three-dimensional model that we're going to create. Gone are the 2D days, right? We're not drawing this, in Illustrator and Photoshop. We're making true three-dimensional models starting today. And you're going to be making the locomotive and the coal car at the exact same time. And all the wheels and all the railroad tracks. It's going to be a lot of fun. All right, let's jump back over into Modo and kind of pick up right where we left off. Last week we spent a lot of our time focusing on the basic interface and learning how to work inside of this really conceptual, weird, wacky environment, right? We talked about the importance and the role of all the axes inside of our three-dimensional space. We talked about the origin, some landmarks inside of our three-dimensional scene that helps us navigate. Let's just talk real quickly. Let me do this. Let me just import some geometry here. I'm going to revisit that exact same teapot that we were using last week. So by going to the top of the screen where it says Geometry and choosing the Unit Primitive series of tools, I'm then going to go into In Current Mesh, Teapot. And there's my little teapot. There it is. Okay, hold on a second. Let me just change my interface to make it look like yours. And I'm also going to turn on my grids and my work planes. I often turn these elements on and off when I'm working in other classes, so bear with me. All right. So here's my little teapot, chilling at a very important element inside of our three-dimensional universe, at the origin, the center of our solar system, if you will. Last week, we spent some time talking about the role of each one of the three axes that we're going to be designing within. What are those three axes? Pop quiz time. X, Y, and Z. Now, if you were to describe the role of the x-axis to someone who's completely new to this, how would you describe the role of the x-axis in simple terms? Left and right. I like it. Also, the horizontal axis. So the inverse of that would be the y-axis. So what role does the y-axis play? Up and down. Now, the tricky one, the one that's new for a lot of folks in here, is the z-axis, the z-axis. What's the z-axis define? Front and back. So forwards and backwards. So we got x, which is horizontal, y, vertical, and z, forwards and backwards, or the depth axis. Now, we have a little teapot here, and you can see just from my viewport that it's pretty cool looking. It's a true three-dimensional model. Let's revisit the viewport navigation controls that will allow us to inspect this model from a number of different angles inside of our three-dimensional scene. How do I rotate the view of my scene? Yeah, Option left mouse button. Option left mouse button will allow you to orbit around in the scene. And orbit's just a really fancy word for rotate. Now, if I wanted to move my camera left, right, up, and down like this, what's the keyboard shortcut that allows me to pan? Option Shift, you got it. Option Shift left mouse button. And then finally, the zoom. What's the zoom? Yeah, Option Control in combination with the left mouse button. Now, you're more than welcome to use the middle mouse button, scroll, to do the zoom action, but you're going to find you're going to get a little bit more, finer control if you use the keyboard shortcuts. So if you don't have a teapot, you can go to the top of the screen. Now, did you already create a teapot, Criff?
I attempted to, and then it said that I created a mesh, and then nothing appeared. I pressed A and nothing.
Okay. Let's do this. Let's go to Geometry, Unit Primitives, In Current Mesh, Teapot. Great. If you haven't already, please commit those keyboard shortcuts to memory. You're going to be using these seemingly every other second inside of Modo, so it's really important that we have mastery of these viewport navigation controls before we go forward. Now, we want to do a little bit more than just look at our models, right? We want to be able to go in and very quickly manipulate them, move them around our scene and rotate them and scale. This is where your homework assignment from last week really comes in and play. Modo is built along a very, very important kind of paradigm. All things begin and end from this paradigm. It's the selection paradigm. What is that selection paradigm? Does anyone remember from last week? Double click. You're in the ballpark, right? Yeah, I like the way you guys are thinking. Yeah, we're in the ballpark, but remember, the selection. You're very right. Remember, in Modo, everything begins and ends with a selection, right? If we want to edit something, like specifically, if I wanted to move the spout of my teapot, I have to select it, right? If something's edited, or if something's selected, that's going to be edited. If nothing's selected, what's going to happen? Everything is going to get edited, okay? So if I need to focus and direct my computer to only manipulate and change the polygons that I want to leverage. In my case, I want to go in and start messing with that spout. Now talk to me about the specifics of the selection engine inside of Modo. How do I select a polygon? What's the first thing we got to do? Click on what? On the spout. Before we even do that. Polygon. Yeah, we have to change our selection set. We have to tell the computer precisely which 3D component we want to work with. In my case, I want to work with polygons. So by going to the top of the screen and choosing the polygons selection set button up here, now I can go in and you can probably begin to see the highlight color as I roll over all these polygons. What enables me to select the polygon? Clicking it with which mouse button? Left click. Okay, we're a left click centric selection system. If I double click on it, what's going to happen? Now, did it select all the polygons on the teapot? No. What did it select? Only the polygons that are connected or welded to each other. Important distinction to remember. How do I drop a selection? Maybe I accidentally selected the spout and I wanted to really select the handle. Okay, now there's some confusion in here and I want to make sure that everyone's clear. The spacebar actually doesn't deselect your polygons, right? What does the spacebar do? It changes the selection set, right? It cycles, it rotates between the vertices, edges, and polygon selection set at the top of the screen. So if I hit the spacebar here, it just cycles between all these different selection sets. I'm currently on vertices. Watch what happens when I return to polygons, though. What's still selected? The spout. I didn't deselected it. I just changed the component that I'm able to select. You got it. And we don't even need to double click. Just a single left click in the background of our scene will drop the selection that's currently active. Just like that. What's another way? Shift? Yeah. Let me show you. Well, let's also keep in mind that let's be really specific here, okay? Now, like when you guys are saying Control and Shift, those are going to add and subtract polygons from an existing selection, but it's not going to drop the selection in its entirety. So don't rely on that Control double click to deselect your stuff. Just a single left click in the background will do the job. Escape is also going to drop your selection, okay? Now I'm going to go to the center of my teapot, just like we did last week, and select some polygons along the center here. How do I add more polygons to an existing selection? Shift, right, you got it. So if I hold down the Shift key, and then just select some additional polys in the center, there we go. I'm on my way. Now I've got a little sloppy over here on the outside. How do I subtract polygons from a selection? Control, you got it. Just like Photoshop, which makes it really kind of handy. Here we go. And we're on our way. What if I wanted to select all 3 pieces in one mighty fell swoop? How could I do that? I love it. Absolutely. The middle mouse button is going to produce a marquee selection tool. So middle mouse button, click and drag, and it's going to select all of the polygons that were in the center of that marquee selection. There we go, on our way. Da, 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 da. Now, if I had done the right mouse button, what would have happened? So I'm holding down the right mouse button now. You got it. And only the parts of the model that are facing you as the user. The polygons that are on the back side of the model have not been selected. So middle mouse button is our guy. All right, let's go ahead and just select the spout here. Your homework inspired you to begin to work with the move, rotate, and scale tools. How do I move my little spout from one part of my scene to the other? So I got my spout selected. I heard the keyboard shortcut. What was it? The W key. Absolutely. Let's kind of refresh our memories as to how we work with tools inside of Modo. Tools, our Modo tools are kind of like our car, right? We have to turn our car on, we drive our car to school, and then once we get to school, what do? You park it, right? And then do what? And turn it off, right? Please turn your cars off, because you'd be like out of gas by the time we get back. And that's bad, okay? So we got to turn our car on, we use it, and then we turn it off. Our tools are the exact same way. We turn our tools on, we use our tools, and then we turn them off. What happens if we don't turn them off? They're always going to be active, and they're always going to be applied to our scene. So it's kind of dangerous to leave them on. How do we turn on a tool?
Click the button.
Click the button. You can also hit the keyboard shortcut. Okay. Now I'm just going to hit the Move button. As a refresher, I'm in the Basics Tools tab. There's the Move button right there. And we, just so you guys are aware, we get a couple visual confirmation cues from the interface that reminds us that a tool is active and is on. These are things that your subconscious is going to begin to look for as you become a little bit more skilled inside of Modo, okay? Like in our three-dimensional scene.
What does GLV stand for?
Graphics language, I think? Yeah. All right. With the Move command, we're able to go in and very quickly transform our spout anywhere we want within our scene by clicking on these little arrows. What do those little circles mean?
You move 2 things at the same time.
Can you be a little bit more specific from things? 2 axes, absolutely. There we go. There we go. I love it. So we're going to be able to move this spout along 2 axes simultaneously. Now, what is the tip that helps us understand which axes we're going to be transforming this object along? The color. What is it about the color?
The color of the circle corresponds to the axis.
Bingo. There it is. The color of the circle that we choose represents the axis that we're not going to be moving this object along. So if I was to pick the green handle, which axes am I going to be moving this object along? X and Z, the red and the blue. Okay. I use these coplanar handles a lot. They make navigating and moving my objects in my scene really, really fast, especially when I've already defined the placement of this object along the y-axis. Okay. Oops. All right. So I'm done working with my Move tool. How do I turn it off?
Click it.
Click what?
The button.
The button. You got it. So if we turned it on by clicking the button, we turn it off by clicking on the tool icon and the button itself. Boom, now that tool is off. If you look carefully in my full interface, the interactive tool handles in my viewport are gone. All the tool options are gone. The orange highlight color in the background of the button is gone. So 3 things that immediately tell you this tool is off. Okay? There are a number of different ways that we can drop a tool to deactivate its influence from our scene. Give me a couple other ways. Spacebar. You're going to see me or probably hear me using the spacebar a lot to drop the tools. It's probably the fastest way to drop tools and to deactivate them in our scene. It's not the only way. There's one other way. Escape is going to do it. Escape. Actually, I guess there's 2 other ways. And then finally, the Q keys. The Q as in Quebec. That key will also drop a tool. And it's kind of a little bit of a a slight, because you're really not dropping the tool, you're activating the selection tool with the Q tool, but it still works the same. In addition to the move tool, we also have the rotate tool. Pop quiz, what's the keyboard shortcut for rotate? E. Move is W, rotate is E. Look down at your keyboards, what's the scale tool? R. Does anyone know when Talk Like a Pirate Day is? I always love Talk Like a Pirate Day. It is. This is an official holiday. Everyone's supposed to talk like a pirate. I know, right? You guys have never heard about Talk Like a Pirate Day? Oh, it's like the coolest holiday in the world. It's fantastic, right? You're allowed to dress up like a pirate and talk like one. Once I figure out when it is, I'm totally doing it. Huh? It's coming up soon. Yes. Yes. I love it.
How do we change the selection tool from lasso to the square one again?
Good question. So Dylan is frustrated with the lasso selection type, right? If you want to get a marquee selection like this, or maybe audition one of the others, you can go to the top of the screen where it says select, and then towards the bottom we have lasso style. I like rectangle, but find one that works for you. All right. Questions so far? That basically is as far as we went last week. So that was kind of last week's content condensed into about 30 minutes. Good review. It's important that we review these ideas before we go forward. Now I want to get rid of my teapot. How do I delete some polygons? Which delete though? Huh? Well, on the Mac keyboards we have 2 buttons that say delete. Which one? Get a 50-50 shot at getting it right.
The one over the arrows?
You got it. I love it. Dylan's got it right. The one over the arrows. So the delete key that's over by like the end key and the home key, all that jazz, okay? Huh?
It's got the little pointer.
Yeah. Which one are we not going to hit? Yeah, the traditional backspace key, because that's not going to delete all of the components that are associated with our surface. As an illustration of that, I'm going to turn on the visibility of all my verts on my little piece of geometry here. And then if I hit the backspace key, as you can see, all those verts are still kind of hanging out inside of my scene. This is bad. This is very bad. We don't like this, okay? This is actually bad modeling. We don't want to have floating geometry that's not connected to a surface inside of our model. This, believe it or not, causes a lot of issues a little bit further down the line. So you have to turn the visibility of your vertices on to really see the impact and the difference between the two. So if you want to show your verts, which I encourage you to do so, put your mouse cursor in the center of your OpenGL viewport and hit the O key. O is in October. And that's going to bring open your viewport properties. Under the Active Meshes tab, simply enable Show Vertices and you're on your way. And then once you hit the Delete key, the one over by the arrows, you can delete all the surfaces that are currently living in your scene. Okay. During last week's homework assignment, I provided you with a scene file that included everything that you needed to be successful in that homework. Well, this week, the only thing that I'm going to be giving you guys for your homework is an image. This image is what you're going to build your model from. 100% of the things that you create this week are going to be built by you guys. So we're going to spend some time today talking about the basic shape creation tools, and there are a number of them. We'll go through some of the rock stars here in a minute, but going forward, we have to build things. We are the makers on campus. We actually create stuff, okay? All of our shape creation tools can be found inside of that Basics tab. And it's, the Basics tab is really the most important area inside of our toolbar because it's home to all of the tools that we're going to be using basically like every other second, okay? The first 2 rows in that toolbar are dedicated towards all of the shape creation tools. Let me zoom in, we can take a look at them. Okay. So there they are. There's all the basic shape creation tools. We can create cubes, spheres, cylinders, cones, toruses, which is a fancy word for donut. We can also do something really cool. We have a tube tool that will create like tubes. We have the pen tool, which will allow us to create custom shapes pretty quickly. The one immediately to the right of that is the text tool, where we can create true three-dimensional text inside of Modo. It's pretty fantastic. It scans all the fonts that are installed on your machine and makes 3D geometry from that. It's pretty rad, right? If you look at a number of the shape tools, you're going to see a common UI element in the bottom right-hand corner. What does that little arrow mean? The little dark arrow in the bottom right-hand corner of a number of the tools inside those top two rows.
There's more options.
Yeah, whatever you see, this is something you see in a lot of computer applications. But that little dark arrow in the bottom right-hand corner of the button says that there are tools nested inside this button. So if I go into the sphere tool and left-click and hold on the button, you can see the tools that are nested in that part of the interface. And I got sphere and ellipsoid. Under cylinder, we have cylinder, capsule, and I'm very, very happy to see that they've included an arc now. This wasn't actually part of the original tool set. Of course, in here we have solid sketch, which is kind of fun. And yeah, it's been around for a bit. And then in the pen tool, this is where we can find a number of other different curve types that we can create. One thing about the pen tool, and this is usually the source of a lot of confusion for you guys, the default pen tool in Modo does not underscore in big, bold, flashing letters, does not behave like the pen tool in Photoshop. Okay? Our pen tool creates polygons. If you want a pen tool that works identically like the pen tool in Illustrator or in InDesign or in Photoshop, what you're looking for is the Bezier curve. And it's really neat that we can draw Bezier curves right here in Modo with the default tools. Okay. This is where we're going to begin our modeling process 9 times out of 10. So get used to coming over here and selecting all of these tools. Working with the shape creation tools is a little bit different than working with the basic transform tools. And let me show you why. I want to start off by drawing a cube. And I would encourage you guys to follow along. Get your hands dirty working with some cubes. So with these shape creation tools, clicking on it, of course, we get the orange background for the icon. We also get some tools over here. But what do you see in the OpenGL viewport? Nothing. With the move tool, simply activating the tool yielded you some handles, some tool handles on your selected mesh. Well, the transform tools, move, rotate, and scale, are basically the only tools that are going to initially give you something to do in the viewport. Everything else requires you to single left click inside the OpenGL viewport to apply the tool to our scene. So this is like as if we've gotten in our car, we've turned it on, but have we stepped on the gas yet? No. Okay? Let's click on the viewport, step on the gas if you will, and start drawing a cube. I'm just going to do a left click and drag in my OpenGL viewport and draw a cube. Left click. We'll get to that in a minute. And there we go. And there we go. Now I haven't dropped the tool yet. I want you to look very, very carefully at either your screen or at mine. Because most of the tools inside of Modo are going to give you some additional kind of widgets, some on-screen helpers that will allow you to continue to customize the parameters of this tool. With the move or with the cube tool, you get those little colored cubes going around the borders of our little shape. For me, and the way that I've orientated my scene, I'm getting some little blue cubes that allowed me to change the placement of my cube, or excuse me, to change the width of my cube along the z-axis. So I can left click and drag on these. I can drag on this one, make it smaller. In addition, we also get some move handles at the center of the cube. And this is really kind of neat because now I can create a cube and place it precisely where I want it to go in one operation. While the tool is still live and on and active, we get access to all of these little on-screen widgets. Watch what happens when I drop the tool. What happens? It's so easy, it's hard. They're all gone, right? All that stuff goes away. We don't have any sort of object history or tool history inside of Modo. So it's important that you're confident with your modeling choices before you drop the tool, because some tool options are only available to you while the tool is on. Good 3D modelers, and this is something that you'll experience firsthand in here, good 3D modelers are kind of like good chess players. We're constantly thinking like 8 or 9 steps ahead of the game to ensure that what we're doing now and how we're creating and setting up our scene, or how we influence this now, or how we create now is going to influence what we're able to do 8 or 9 steps from now. Okay? Some of this is going to come from experience, but you'll get there. All right. Now, if I reactivate the cube tool, am I going to get all those handles back? No. Keep that in mind. Let me delete this guy. And I'm going to draw a cube one more time. So just left click and drag, and I can draw out a cube. At the moment, is this cube actually a cube? No. It's a square. It's a 2-dimensional square. Yeah. Reading my mind, Earther, as always. Let's orbit around to the back of my shape here and see what we can see. Whoop. What do we see? Seemingly nothing, right? And let's define this. Let me drop the tool for a second and talk about some computer graphics stuff. Warning, science content. Science content, okay? In computer graphics, all surfaces have a defined direction. That defined direction is called a normal. For whatever reason, it's called a normal, right? That normal basically determines the orientation and the way, if you will, that this surface is facing inside of our 3-dimensional scene. Let me show you this, okay? Let me show you this. I want to put my cursor back in the OpenGL viewport and hit the O key one more time to bring open my viewport properties. Down in the visibility section, right here, I'm temporarily going to activate Show Selection Normals. And then I'll click off of it. If I select my little square here, you see that dotted line that's coming from the center of my surface? Can you guys see that? That is an indication of the surface normal, the direction this polygon is facing within inside of our scene. Make sure you select it. Select the cube. Huh? So did you activate Show Selection Normals? Yes. Select your cube. Or select one of the polygons in your scene. Okay, you're not going to see this dotted line until you select something. When our perspective, or when the render camera's perspective, is within a certain angle of this selection normal, or of this surface normal, we're going to see that shape, right? We're going to see that polygon. But the moment that angle changes, so like when the surface normal is facing the opposite direction of our view, what's going to happen? We're not going to see anything. It's going to become invisible, okay? The backs, if you will, of all of our polygons are invisible. The only thing that we're ever going to see are the fronts of our polygons, which is why the back is invisible, okay?
That's why there's clipping in video games. If you're having the camera go to the wall, you see through the face.
We see through faces, that's right. Because polygons only face one way. If we see it from the other side, it's just going to be invisible. Okay. Once again, I want to delete my polygon. I'm also going to turn off Show Selection Normals by going back to the exact same menu I was just in. Don't need that anymore. And I'm going to make an additional cube. This time, when I draw my cube, I want to make it into an actual piece of 3D geometry. With the cube tool, we can extrude our square into a 3D cube by manipulating that center handle in the middle of our cube. For me, it's the red one. So if I grab that little red cube and drag it to the left, I can interactively extrude that cube into 3 dimensions. There we go. Drop the tool, and I'm on my way. Life is good. And now I have a true 3-dimensional cube. Yeah, Carissa. Good question. Actually, that's a beautiful question. Let's go back and explore that. One of the great things about the Modo toolset is that there are additional options in a number of the tools that will change the behavior of the tool. Let me delete what I have, and I'm going to redraw a cube, and we can explore some of those options. Now, notice that I have not dropped the tool yet. Let's check it out. Over here in the cube tools, we have a lot of different channels that drive the properties of this tool. Of course, the position of the cube, the size of our cube, those little colored cubes that we were clicking and dragging on, we're really just changing the values in those value boxes. The one that we want to look at is segments. The default value for segments is 1, but what happens if we start to increase those values? We're going to add additional edge segments into our mesh, like this. Check it out. Maybe I'll do like along the z-axis, I'll put 5 here. Boom. And it adds 5 new edge loops along the z-axis. Same with on the y. Boom. I can add more geometry on the fly here. I can go pretty crazy with this if I want, and really increase the resolution, as they say, of our mesh. These tool options are going to allow us to create some very compelling results with very simple, meager beginnings. Let's drop the tool. Any questions on the cube tool? It's a pretty easy tool. I think you guys will find it pretty simple to work with. All right. I'm going to skip, just for one moment, the sphere tool. We're going to come back to this. But I want to spend some time talking about the cylinder tool. A majority of our world is constructed out of squares and cylinders. Shoot, just look around this room. An analysis of all the shapes in this room will yield you the idea that almost everything in this room is either a cube, a cylinder, right? The iMacs that you're sitting in front of, just skinny cubes, okay, that are standing on top of a skinny cube that's been bent 90 degrees, which is sitting on top of a whole bunch of skinny cubes that make a desk, right? The floor, a cube, that post, a cube, the blinds, a cube, the door, a cube, the wall, the cube. Almost everything in this room is a cube or a cylinder, including us. What basic shape are we? Cylinders. Cylinders. The human body is really constructed from a whole series of cylinders, right? Everything in our world is a square, a cylinder, or a sphere, which is why I'm putting so much emphasis on it, all right? Cylinders are created almost the exact same way as a cube. Let's explore it for a second. I have my cylinder tool active, and I'm going to left-click and drag, and I draw out a circle. We get those very similar and comfortable manipulator handles that will allow us to change the radius of our cylinder. The center one, in my case, the red cube, allows me to extrude that shape along the x-axis and create a three-dimensional cylinder. Before I drop the tool, however, let's look at a number of its properties that will change what's been created. Let's go down and check it out. There's 2 that I want to draw focus to, sides and segments. The sides of our circle is going to determine how close to a perfect circle we're going to create. If I was to dump this value down to like 5, which shape would I create? Go back to geometry class. Pentagon. You got it. Let's check it out. So if I put this to 5, hit the return key, check it out. It transformed into a pentagon. And this is all live, by the way. You can increase it, you can decrease it, and life is good. I can even go down to a triangle. I think that's, yeah, I can't go below a triangle. All right. So the higher this value is, the closer and closer we're going to go to being a perfect circle. Okay. Now we want to kind of keep this in check. For me personally, 24 is kind of the max, okay? 24 sides is kind of the max. At times, occasionally, I'll jump into the 40s and 60s, but that is very, very rare, okay? The more geometry we have on our models, okay, the more polygons we have on our models, the longer it's going to take to render. So we got to manage this. Don't go crazy with it, okay? In addition, we also have the segments.
How do I get back to that?
Back to what? Increase your sides. I'm rocking 20 right now. Mm-hmm.
I keep changing the size, but it won't change it. It's still accepted. Like I put 5 in one place.
Hit the return key.
Okay.
Is the tool still active?
I don't think so.
Oh, yeah, if the tool,
Never mind.
yep.
Okay.
Once you drop the tool, you'll no longer be able to change this value. Okay, so we talked about the role of the sides options. Let's talk about the segments. If you look very, very carefully, you can actually see the segments being drawn along the length of my cylinder. For me, most of the time, I usually leave my segments as 1 because I want to be able to control later on down the line how many additional edge loops are created along the length of my cylinder. But you can change this. Let's just return this to 1, boop, and that's what we get. Pretty cool. Sides and segments, 2 options inside the cylinder tool that you're going to be working and leveraging a lot. And don't forget, you can always go back in and change the shape before you drop the tool. So this is a great way to make ovals and ellipses and what have you. Now I've made an ellipse. What if I wanted to create a perfect circle? And I mean perfect.
You make the Y and Z X radius.
You got it. Arthur's actually zeroed in on the values that we need to kind of control. If I return to the cylinder tool and draw out a shape, check it out. We have 2 values here, or actually 3 values here, that define the radius of our cylinder. If you go back to high school geometry, you know that if a circle has an identical radius on 2 values, it's a perfect circle, right? I can copy and paste these values from one channel box to another. So if I grab, maybe I want it to be 855 millimeters, so I'll just do Command C to copy. Go to this one, Command V. Command V. There we go. Or my computer's wigging out. The clipboard's empty. Let's try that again. Command C, Command V. There we go. And it's somewhere in here now. Let's just try that again. That was an epic fail. There we go. Oops, I dropped the tool. Talk about habit.
So you can never go back and deselect it?
Yeah, once you drop the tool, that's the shape that you have. You'll have to restart it. Copy and paste the values. If the radius on both those values are the same, you get a perfect circle. However, this is a tremendous amount of work, and it requires a whole series of extra clicks that Pat no likey. Okay? Let me show you a great power user shortcut that will help. Often, we want to make perfect circles for every single thing that we do. But I don't want to have to go through this process every single time. This is lame, man. No way. Let me show you the power user shortcut, okay? Now, I want everyone to do this with me together as a class. It's important that we establish this muscle memory right now, because making perfect circles is kind of one of the things that you're going to be doing a lot, especially for this assignment, right? All the fuselage for your train, circle. The little exhaust pipes, circles, okay? The wheels in the train, circles. There's a lot of circles on this train, okay? So let's explore how we can make a perfect circle without having to go in and change all these radius values. All right. I'm going to start with an empty scene in my OpenGL viewport. Fire off the circle tool, and here's the sequence. Now, you need to be a little bit more disciplined when using the cylinder tool, trying to make perfect circles. So honor the sequence, okay? And you have to follow it precisely, otherwise this isn't going to work. What we're after here is a perfect circle, not a perfect cylinder. So I want a disk, basically. That's what I'm after. When we generate a disk, it gives us options, okay? It gives us a lot of options. It opens up step 4, 5, and 6 for us later on down the line. With the cylinder tool active, single left click inside your OpenGL viewport. Just single left click. You can see that the computer's drawn some move handles. That's step number 1. Step number 2, move your cursor away from these move handles. Move it away. And look, I'm moving mine pretty far off over in here, okay? Step number 3, hold the control key down on your keyboard. Step number 4, drag to the left or right, and a circle will be born. Let's do this again. Cylinder tool, single left click anywhere in the scene. Move your cursor away from the tool handles. Hold the control key, left click and drag left and right. That seems to work the best. Everyone do this. Make about 80 different circles real fast. Create the muscle memory. I'll walk around, make sure everyone can do it. All right? Now, if you're making a perfect cylinder, here's the mistake that you're making, and I can see a lot of you guys doing this. If you leave your cursor at the location of those handles, and then control key, left mouse button, and drag, you're going to create a cylinder. This is bad. No liking. We don't want that. What we want to create is a disc, like this. A flat plane. Everyone make some. Make about 20 of them. Don't stop until you know you can do this without having to think about it. Absolutely. Let's do it one more time. So step numero uno. After we turn on the cylinder tool, just single left click in the OpenGL viewport. Step number 2, move your cursor away from the tool handles and make it some distance. Step 3, hold the control key. Step 4, left click and drag. And you'll generate a perfect circle every single time. Say again? Physically move your cursor away from the handles in the center of your screen. If you leave them there, what you will create is this. We don't want that. We want this, a disc. All right, absolutely. Single left click in the OpenGL viewport with the cylinder tool on. Now, check it out, Criff. I'm going to physically move my cursor way out over here. Away from my tool handles. Step 3, hold the control key down. Over here. I'm sorry, is it difficult to see? Okay, it's down here at the bottom. Doesn't matter where it is, it's got to be very far away from your tool handles. Hold the control key, and then left click and drag. I've noticed that sometimes you get funky results if you left click before you hold down the control key. This is where that disciplined idea really comes into play. Follow the sequence and it will work every single time.
I think like two of them, and the third one turns into like a cylinder.
It's probably the location of your cursor in relationship to the tool handles. Yeah.
So let's say I make the circle, the fast circle, and I let go of the click, and then I want to resize it again. And I do it as a cylinder, though. Is there any way to resize it again, or is it's a cylinder? I try again.
If you notice what I had, when you say resize, which one of the tool options are you manipulating?
The same one. So let's say I did it correctly, like I did that, let go for a second, and I want to do it again. So I click.
So you drop the tool.
No, I don't drop the tool.
Drop the tool. That may be your issue.
I didn't drop the tool.
Drop the tool. Try it again by dropping the tool after you finish drawing that first circle.
I was just going to ask, once you use the select that close tool, transformation tool.
The scale tool? Yeah. Let me see what you're doing.
So, make the circle, and then
Perfect.
let's say if I want to do it again, so I push
No, nope.
It is
No.
center.
Drop the tool. If you want to make another one, drop
I'm
the
just
tool.
wondering why if this because it just makes the center, yeah. Okay. Then there's-
Drop the tool. Yeah.
I need to highlight first.
Now, what are you trying to do? Are you trying to extrude this into a three-dimensional shape?
I was just saying because I was just wondering why on the original. So I'm gonna do that, and then if I try to do it again, then it makes.
Yeah, you did. That's because
I
you
was
did.
wondering why it just doesn't.
Yeah, well, it's because you're not dropping the tool. I hear frustration.
Yeah, it's really irritating. Okay, so boom, right?
Good?
Boom.
Nope. Yeah, now move your cursor away. Yep. There it is.
I know. I can get like 2 of them in the third one.
Okay, show me. Good? It knows when its master's here. Gotta be disciplined. Take it slow. Don't rush through it.
Is there a quick way to select the cylinder tool?
No, I don't believe there's a keyboard shortcut.
Oh, okay. 'Cause every time I press control and to do the thing, I just press spacebar to get rid of it. That way I don't accidentally mess with the this. But that just deselects the cylinder tool too.
Correct. Yeah.
So you just have to manually choose it.
Yep. There's no freebies in 3D. Nothing comes for free. Unfortunately. Yeah. Okay. So you've already applied. Let's start over. All right. Walk me through. Yep. Walk me through. Just do it for me. Go. Oh, so here's your critical error. Yep. Go ahead and delete that. Let's start again. So single left click. There you go. Now move your cursor like out over here. Yeah, move the mouse. You got it. You got it. You got it. Keep going. Keep going. Keep going. Yeah, put your mouse right there. Good. Now hold down the control key. No, you didn't hold down the control key. Yeah. Try again. There you go. Awesome. Yep. Now left click and drag. Yeah, keep going. Keep going. Keep going. Bam. There it is. Do it 10 more times. Perfect circles, Nathan. Perfect circles. Try it again. Let's try it again. Good.
And then sometimes when I do that,
Okay.
it just randomly mixes around.
Oh.
Like that.
Yeah. So what probably happened there is that you held the control key down after you left mouse clicked. Yeah, you got to hold it down before you left mouse click. What you got, Andy?
1 circle, and I'm pretty sure this computer hates me.
Okay, show me. What's going on?
Well, first off,
Drop your tool. Let's make another one.
you have to reselect the tool.
Yep. Good. Now you're struggling a little bit because somehow your snapping engine got turned on. Just click on that button. There you go. Do it again. Show me again. Nope. Don't. Nope. You got to turn the tool off. There you go. Turn it back on. There you go.
I didn't sleep so well last night.
Oh, that's okay. Neither did I. Good. You got it. Just be disciplined, okay?
I did it.
Look what you're doing.
What am I doing?
As always, ahead of the pack.
Yeah, really quick question.
Of course.
That's a long square on the rail, right? It's a square, not a cylinder.
For what piece?
The blue rail right here.
Yeah.
Okay.
You got it. Just a cube. All right, looking good, everybody. Looking good. There's a lot of discipline that's required inside of 3D modeling. As you heard me mention earlier, nothing comes for free in the computer. The computer's never going to help you. Okay, you'd think that we'd have these wonderful machines that will automatically create these models for us, but they're not. We have to operate this machine, and we have to operate it with an understanding that there's a sequence that is required for us to follow. Herein lies kind of one of the larger challenges, to be honest with you, with 3D graphics. And if you're working inside of Photoshop or to a certain degree inside of Illustrator, the tools aren't going to stop you from moving forward, right? In the computer, our tools are absolutely going to stop you from achieving steps 4, 5, and 6. So be disciplined with it. Follow the sequence, and you'll be okay. All right. Pop quiz. I have a bunch of shapes on my screen, a bunch of them. I want to delete all of them in one mighty felt swoop. What should I do? Delete key. And this revisits the idea of our selection paradigm, right? Whatever is selected will be edited. If nothing's selected, everything is going to be edited. So I want to delete everything. So by unselecting or by not having anything selected, the delete key will kind of nuke everything in my scene. Bye-bye. Okay. Yeah. Without a doubt. Without a doubt. Only you can prevent forest fires. Only you can prevent forest fires. Okay? Yeah. Okay. So now that we have a little bit of mastery with the square tool and the cube tool, let's advance on just for 1 second and explore the cone tool. The cone tool is kind of fun. It behaves almost identically to the cylinder tool initially. So if I wanted to create a perfect cone, single left click, move my cursor away from the tool handles, hold the control key, and then left click and drag. But we haven't created a cone first. We've only created the base of the cone. We have to leverage that center handle to pull out a spike. Let's do it. Whoop. All right. And then drop the tool. All right, so that's the cone tool. Now, a lot of folks get confused as to why the cone, and specifically the spike of the cone, is facing the way it's facing. And it leads us into a much larger conversation about the work plane. Last week we talked very, very briefly about the work plane, and the work plane is awesome. Okay, I love the work plane. For me, the work plane is one of those Moto features that is worth the price of admission. Okay, I can't model without the work plane anymore because it's just that useful. The work plane is an interactive snapping grid that controls the placement, the initial placement of almost every single one of our tool handles. If you're coming from another application, you're probably used to working inside of this Mod Quad environment. If you do any sort of modeling in 3D Studio Max or even Maya or Cinema 4D, you have to work in this environment to accurately control the creation of your shapes along predetermined axes. Perhaps I want to have my cone be created on the XZ axis, which is like the floor, right? And I want the spike of my cone pointing towards the positive Y axis, okay? In this view, it's really easy to do that. Without the work plane in a single viewport, very difficult to do that. The work plane, as I mentioned before, is an interactive snapping grid. It's always on. You can't turn it off. However, we can toggle its visibility, but we can never toggle its effect. It's always 100% influencing every single moment that we're alive inside of Moto. We want this, however. This is cool. Does anyone remember what the work plane looks like? I think I briefly touched. The gray, yeah, you got it. This gray little box down in the compass represents the current orientation of our work plane. If you look at your OpenGL viewport, you're probably seeing the work plane. If your monitor is really dark, it may be a little bit difficult to see. But it's that light gray grid that's always in your scene. You see this light gray grid down here? That's the work plane. You may have been confused about the work plane because the work plane changes its orientation. The orientation of the work plane is controlled by the user's perspective within inside the three-dimensional scene. Let me show you what I'm talking about. As I orbit around my little cone here, watch the orientation of my work plane. Right now, it's kind of floating along the ZY axis. You can kind of see it, okay? See all these little grid lines. But watch what happens to my work plane when I start changing my view of my scene. I want to orbit, 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 orbit. Watch, 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 watch. Boom. Do you see it flip? Boom, 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 boom. It's flipping back and forth. It's changing its orientation based on where I place my perspective inside my three-dimensional scene. Let me do it one more time. If I orbit up, you'll see that the work plane snaps to a different orientation within the scene. Here it goes. Boom, right there. Now it's snapped along the XZ axis inside of our scene. This is an important thing to kind of keep your eye on because, as I mentioned, every tool is influenced by the work plane. Believe it or not, you guys you weren't even aware of this while we were working with the cylinder tool. But let's draw focus to this with the cone tool. With my work plane orientated along the ground, the XZ axis, watch what happens when I create a cone. The base of the cone is going to be created parallel to the work plane, as if it's glued to the work plane. Check it out. Here's my cone. Single left click, hold down the control key, left click and drag. And then if I pull up a spike, the cone is perpendicular to the work plane. Let's do it again. I'm going to drop the tool this time. I'm going to orbit maybe up a little bit. And you can see the work plane has changed its orientation again. Now it's going this way. I'm going to fire off the cone once more. I'm going to do the exact same thing. Single left click, hold the control key, left click and drag. Drag out the spike. And now look at which way the cone is being created. The base of the cone is always going to be created on the work plane, as if it's parallel to it. But once we pull up the spike, the end result is going to be perpendicular to the work plane.
I'm a little confused. Why did
Most people are.
change like that?
We want it to change. Well, we want to be able to control which orientation these tools are influencing our scene.
Because you're saying it changes just by how you're
Yep.
viewing.
Yep.
I'm not sure why that should matter.
Let's check it out. Let's kick it up a notch, as Emerald Lagasse used to say. Okay. Aha. Okay. Let's do this. Maybe I'm going to create a poster that's going to go inside of a wall. Okay. So there is my poster. Ta-da! That's a pretty good looking poster, right? But posters, they need a little bit of curl to them. If you've ever hung a poster in your wall with some thumbtacks at the top, what happens to the poster at the bottom? Kind of curves out a little bit. That'd be something that would be traditionally kind of difficult to do, but with the work plane, it makes it very easy to do. I'm going to orientate my work plane so that it's crossed and so that it's perpendicular right there to my poster. Simply, let's just go, I'm going to deform it a little bit by bending it. The bend tool is going to notice the orientation of my work plane and automatically put its tool indicators perpendicular to that work plane. And now I can bend it like that. Let's also kick it up a notch.
So the Moto's created, they built that into Moto because that's just, it's more convenience or makes sense when you're working on something.
Absolutely. It's fast, it's convenient, it gives me a level of control that in other applications I don't have. Let me show you another great example of this.
Because now at this stage of the game it's not obvious, but
Later on it will be.
later on,
Yeah.
oh, okay, now this makes sense. Okay.
Yeah. And it saves you. You know, if you're making the wheels of your train, right? You know, it saves you really. So for this week, let's just pretend, and this is just really fast, that I wanted to create, this is the fuselage of my train, okay? Well, what if I'm ready to create the wheels of my train? Instead of doing this, pulling out of the shape, dropping the tool, yeah, moving it, rotating it 1,000 degrees, you know, like that to get the wheels. What if I just orientated my viewport ever so slightly differently so the work plane is perpendicular to the plane that I want to create my wheels on, and it saves me from having to rotate them. Yeah. And now they're already orientated the right way. And it's just a process of moving and positioning them into location. Let me show you another example. And this is super advanced, and it's just kind of an illustration of the power of the work plane. So I don't expect you guys to remember what I'm about to do. But the work plane is not something that's just purely a static element that's controlled by the computer. I'm in command of this thing, right? I get to place the work plane wherever I want it to, okay? Which is pretty great. Let me show you what I'm talking about. Maybe I have a cube in my scene, okay? I have a cube. Let me just dock these values back to where I want them to be, okay? Okay. And maybe I rotate this thing arbitrarily. I don't know what value that is. I really don't know, okay? I need to have, maybe I created this cube, I rotated it, and then the next day I come back to my model and say, you know what would be a really cool detail in here? Is to have like a bolt coming off of that slope on my cube, right? Without the work plane, this would be what you'd have to do, right? You'd model the bolt. A bolt. like a bolt. You'd model the bolt. There's my bolt. Okay? Then you'd have to like move it over here, and then you'd kind of have to guess at the rotation parameters, right? And maybe you'll have to look at your scene from the front or from the right. Man, it's a ton of work. And then you'll have to, I'm close. If you look at the angle there, it's not quite perfect. And it's got to be perfect for me because I'm me, right? There we go. And it's still not quite perfect. And man, this is a pain in the butt. Okay, just for a stinking bolt. Okay, I'm in command of the work plane though. The work plane can be moved. Check it out. Since all of our shape creation tools happen at the location of the work plane, what if I change the work plane to be aligned to a selected polygon, like that? Now, when I use my cylinder tool, guess where it's going to be created? At the exact same angle of my work plane. And now, I could, if I wanted to, just move it into position, and now I know beyond any reasonable doubt that that bolt is at the exact angle of that polygon. Well, you're probably saying to yourself, well, Pat, what if I wanted that bolt to be in the center of that polygon? Right? That makes sense, logical. Well, we can do that with the center selected command. The work plane actually has a defined center point. So maybe I center this thing along, it'll be the local x. Let's really make it really obvious so you guys can see the magic happening. I can center this thing on the work plane. Then, whoops, I forgot to select something. That might help. Boom. Now I know beyond any reasonable doubt that this bolt is perfectly centered around the polygon, the slanted polygon, and it matches the angle of that polygon, all thanks to the work plane. It's a phenomenal tool. I can't live without it, to be entirely honest with you. It's the reason why I choose to do all of my modeling in Modo. Yeah, I'm a big super advocate of the work plane. It's great. All right, let's move on. Yes. No breaks. No, yes, absolutely. This would be a perfect time to take a break. Let's take a break. Get up, stretch your legs. Let's take a break. Okay, so welcome back. So before the break, we were spending a lot of our time talking about creating shapes. And all the shape creation tools kind of run along the exact same paradigm. I want to encourage you guys to kind of explore some of those other shape creation tools. It's important that we spend every day talking a little bit about the art of 3D modeling. We spent a lot of time talking about the technology today, right? A lot of tools and a lot of processes and, uncreative things. But it's equally important that we just take a step back and look at the artwork that we're going to be creating, because we are creating artwork here, okay? As I described earlier, this is our goal this week, okay? But often, without color, right? No color? Without color, you got it, without color. But often, this isn't the first image that we see of the object that we're going to build. Now, I know every single one of you guys said, or every single one of you guys thought, when I said you're making a train, you thought about a train in your head, and you drew a picture instantly of a train in your head, right? Everyone did. Some people, picked like a steam locomotive, others were electric and diesel, maybe a futuristic train. Everyone thought of a train instantly in their head. Everyone always has an idea of what they're going to make. That's not the hard part. The hard part is recreating reality, is recreating that idea. That's the true challenge in all this. I can say, everyone, make me an airplane. You go, okay, I got it. But then you start making an airplane, and it looks nothing like an airplane. Where we begin is not an indication of where we're going to end up. We always want to try to start our modeling phase from very simple, meager beginnings. We don't want to start thinking about the final detailed mesh until we have absolute mastery of the overall form. This is what you guys probably thought about when I said you're making a train. A lot of you guys probably said, sweet, I'm making me a train, and this is a picture or something of this level of detail was what your mind created. Do we want to start making this initially? No, right? Because there's a lot going on here, right? How can we create a bolt or a wire or a piece of trim detail around the doors or a logo or rivets before we even understand the overall shape? As I mentioned earlier, we have to be like sculptors. We don't think about the wrinkles on the face or the details of the eyebrows or how someone has a birthmark on their face initially, right? We think about the overall form, the overall shape, and the volume that we're going to be creating our artwork within. That's where we start. This, seemingly impossible to create initially, right? Where do we start? The hardest part in 3D modeling is not the end, it's the first step. Where do we begin, right? What do we draw first? The rough layout, you got it. Now, what's the rookie mistake that everyone makes on every single project? What's the first thing you want to do whenever you start a project? What's the very first thing? Knee-jerk reaction. What's the first thing you want to do? If I said, make your favorite thing right now, what are you going to do? You're going to open up Modo and you're going to start laying down some polygons, right? You're going to start building stuff. That's the rookie mistake, though. The first thing that we got to do at the beginning of every project is to look. We have to see the forms in front of us before we can start building them. Every complex object, and I mean every complex object, starts from a shape analysis, okay? Now, what shapes do you see in this train? Cylinders, right? The wheels are cylinders. The fuselage, cylinders. The little steam pipe coming off the top, cylinders. Bolts, cylinders. There's a lot of detail on here that's nothing more than a cylinder. That's all it really is. It's a fancy cylinder that eventually we're going to edit and change its shape with some very fancy tools that will get us to that final shape, right? How about the house for the locomotive? What shape is that? Cube. What about the roof on top of the locomotive? Cube. Coal car. Cube. The platform the coal car sits on. Cube. The trucks for the train. Cubes. They're all basic squares. We're never going to start with an image like this, or with the idea that we're creating this. We want to spend our time trying to figure out the overall shape, working with as few polygons and as few elements inside of our project file as we can. In comparison to the previous render, would it be very difficult or very hard or very easy to change the location of one of the smokestacks on this train?
Yeah.
Pretty easy, right? If I was forced to change the location of even something as simple as the wheels on this bad boy, would it be easy or hard? It would be very, very hard, right? Because now I'm not working with just a couple polygons. I'm working with millions of polygons that I now have to edit, move, and manage, right? We want to spend our initial time focusing on form and volume and plane. We want to spend our time exploring the shape so that when we're ready, we then can up-res, edit, and add a tremendous amount of detail on something that we know is already rock solid. One of my jobs over the next 14 weeks now is to open your eyes to the forms and the volumes inside of this world. Everything is a simple shape. I am blessed or cursed, depending on how you want to look at it, with the vision of a 3D modeler. Okay? I don't see things anymore. I don't see the world like I wish I can, right? Or I wish I could see it. I see lines. Everywhere I look, I see lines on things, okay? I've been so ingrained in this modeling workflow that I see edge segments on everything. I go into a new place and I'm immediately bombarded with all the vectors from the buildings and the cars, and I see the basic shapes in front of me, okay? It's kind of like Neo in the Matrix, not that I'm like the chosen one or anything, but you guys know the Matrix, right? Love the Matrix, right? Big fan of the Matrix series. You know, Neo, the main character, is the chosen one, and he's prophesied that the chosen one will see the code and be able to manipulate the Matrix as he or she fits, right? Well, there's an iconic shot at the end of the first Matrix film where Neo finally realizes that he is the chosen one, and he sees the code in the Matrix for the first time. Before that, he just sees people and buildings and walls. He sees images. And then he transforms into seeing the computer code that creates those images. Well, my brain's kind of like that now. Okay, I no longer see that camera in the back is not a camera to me. That's a whole bunch of cylinders on top of each other, right? I can see how exactly I would construct that quickly in 3D without too much issue, okay? Your brains are going to be transformed into that kind of thinking pattern, hopefully, over the next 14 weeks, okay? I'm going to ruin the movies for you guys. I really am. I want to ruin television because you're no longer going to be able to go to the movies and just be, wowed by the images that you see on screen. You're going to go, oh, I see a polygon over there. It's going to be horrible, right? But it's part of the learning process, part of the opening our eyes to this new experience. At the end of the day, we're always going to start with these basic shapes, but by the end of the day, we're obviously, of course, going to go back in and up-res and add detail. You're going to come back to this project, actually. As I mentioned before, this project is going to return, okay? The project that you build this week, you're going to continue at a much later time. I haven't figured out when I'm going to drop this lab assignment on you guys yet, but at a much later time, when I feel as though you're ready, then you're going to spend a couple hours up-resing your train. And eventually, you're going to get to something that looks like this, okay? This is the true geometry in Modo. As you can see, this is the model file that this render was made from. It's actually been added onto since that render, because now I have a passenger car. Whee! Yeah, pretty cool, huh? So, whoops, excuse me.
One thing that has been going through my mind is when we're looking at the teapot or the final render like that, they're all smooth, but when I'm starting off making just a cube or a cylinder or something, it's doing the straight edges.
Yeah, we'll get past that. For now, we're just going to hang out in that kind of faceted work environment. In about 3 or 4 weeks, we're going to transition into a new modeling technique called subdivision surfaces that will create those perfectly smooth shapes for us that you see on both my train and in the renders that you see online. So we'll get there. Okay. Let's go back to my renders here for a second. Now, one of the things that you have to consider when you're starting this process is the idea that 3D modeling during the initial rough out phase is additive. We're not deleting any polygons from our scene. I haven't even shown you guys the edit tools that will allow us to slice our meshes, make holes, all that stuff, right? You're only allowed to work, with cubes and cylinders for this assignment. So this is going to be an additive construction process. We're going back to building with Legos now, right? In Legos, if you wanted to make a window, you'd stack a whole bunch of Legos on top, right? And then you'd build, you'd go horizontal across to make the frame of the window, then you'd stack back down, right? We're doing the exact same thing with our 3D models here in Modo to create the windows and the openings for the cab of our train. It's really about a dozen different pieces all working in harmony with each other, right? Because we have one cube that makes the lower panel, another cube that makes one vertical piece, another cube in the center that makes the divider for the window, another piece in the back that makes that back wall, another cube that's on the top. It's an additive workflow. We're not doing subtractive yet. The additive workflow in 3D modeling allows us to work very, very fast. I don't care about accuracy at this moment. I'm looking at shape. I'm looking at form. I'm just trying to figure out how in the hell this thing is supposed to look in 3D, right? We can draw a 2D picture of a train real fast, but drawing a 3D picture of a train, completely different beast, right? Because now we have to work inside of an environment that's driven by depth. The additive rough out process is fantastic because it allows us to be creative. It allows us to look at the overall shapes in a very easy, low polygonal environment. And very quickly, we can create something that looks like a train. Now, of course, we're going to need some help in this. Okay? We can't rely entirely on our eyeballs to figure this out. Whenever we do any sort of 3D modeling, we need some help, right? As I mentioned earlier, every single one of you guys came up with a different idea of what a train looks like. Well, I think it's important that we begin to materialize those ideas. But where do we start? If I ask you to draw a train, it's going to look nothing like the image that your brain came up with, right? I want your images to look exactly like the idea that your brain came up with. So we use reference images. We want to become subject matter experts on the objects that we're creating. We have to look and know and understand our object better than anyone else from all different angles. Because if you don't know what a wheel looks like, how in the hell do you think you're going to make one? Right? So we need to scour the internet and find as many different images as we can about our image. Okay, now I'm going to give you the reference image for this model that you're going to use to build your shape on. But I practice what I preach. Let me kind of illustrate the ideas that I'm talking about here. So if I go over into my Finder and open up the project file that I used to make this very train, you can see pretty quickly that without these reference images, it would have taken me forever to get where I am. Reference images allow us to very quickly understand size, scale, and form. They're going to give us a point of reference. Okay? They're going to let us know and cue us into all those little details that maybe our brain forgot or maybe that we didn't consider. It also helps us establish the spatial relationship between the details. How far are the wheels supposed to be from each other? What does the door trim look like, right? How big is the opening for the door? All things that reference images are going to yield us. So we want to find as many pictures as we can that provides us with a lot of information as to what this thing looks like. Okay? The more images that we have, the better and the more detailed the end result of our model is going to be. Is this cheating? No, absolutely not. This is how we work, right? If we start with a good foundation of reference, the end result is going to be stellar. Okay? It's going to be stellar. I begin every project that I start with a comprehensive analysis and research of the object that I'm going to make. Something as simple as, well, a train's not a simple thing, but something as simple as, something as simple as a teapot. I'm working on some graphics right now for the school. excuse me, and I'm building a Conestoga wagon. The school is about to celebrate its 100th anniversary here very shortly in 2016. Yeah, a lot of people don't realize that the school's been around since 1916. Okay, World War I fighter pilots were trained here at Sacramento City College before they went over to Europe. Pretty cool, huh? Pretty cool. Anyways, so we're doing this whole big kind of kickoff and this branding campaign, and I'm doing some motion graphics and some animations that'll highlight the 100th anniversary of the school. The original school logo has a big Conestoga wagon in it, right? I don't know if you guys have seen our horrible or old school logo. Have you guys seen it? Yeah, it's pretty bad, right? It's not exactly a great logo. I'm happy that we've gone on to a new one. Huh? Yeah. Oh, yeah. It's bad. It's a bad logo. But what I'm doing is that I'm creating a 3D version, a 3D animated version of that logo, and that's going to be the start of a much larger animation that's going to take the school through kind of time periods. Okay. Because in the original logo, it's this weird kind of octagon logo thing, which is strange. And in the center, you got a little hill, and you got a Conestoga wagon with a little oxen going up over the hill, and you got this beautiful kind of sunset behind, a big pine tree. Well, I'm creating this is obviously the art asset for the Conestoga wagon, right? Well, I know what a Conestoga wagon looks like, right? In my mind, when I started this project, I was like, sweet, Conestoga wagon. This will take me a couple hours to pump out. Not too bad, right? Not too bad at all. But I got to practice what I preach, right? I got to start with that muscle that I established way, way, way back in a galaxy far, far away. I got to start with my reference. I got to look through my entire reference catalog, online, anything that I can find, and look for little images that give me details, like this. Phenomenal image that gives me a lot of detail on specifically how the wheels are constructed and what they're supposed to look like. A detail that would have been absent if I hadn't done the research. I really didn't know, to be entirely honest with you, I didn't know that there was this little box on the side of a Conestoga wagon. I didn't think that was there until I started looking at the reference images, and like every wagon had it on there, so I was like, well, mine's got to have it, right? If I'm recreating reality, these small little cues remind us of the images that we're accustomed to seeing. Believe it or not, the moment we start taking away these details, and the moment we kind of forget the roots of this project, that's the moment that our audience stops believing that this is a real thing. We're no longer suspending disbelief. They're going to think, oh, this is computer generated, and at that moment, mission failure. Okay?
It's funny you have the sloped roof, and I always thought, your render looked almost cartoonish, but looking at the real deal,
that's the way, I know, right? Yeah. And I even toned mine down a little bit, to be entirely honest with you, because it was kind of cartoonish. And not to toot my own horn here or anything, but that sloped roof, the way I model and the way I approach things, I try to be extraordinarily accurate. And one of the things that we'll talk much later in the semester about is a big grand issue called polygonal flow. If we have good polygonal flow, our model is extraordinarily easy to edit. Getting that sloped roof was not a trivial thing. Was not a trivial thing. I spent probably more time on that sloped roof than I should have. But it looks great, and it's perfect. It's going to texture beautifully. It's rendering great already. Very, very pleased. I know, right? So we got to start with reference. The more reference we have, the more accurate our model is going to be. Every image that we find is always going to produce some sort of value. Don't throw away images. This is a hokey model, if you will, of a wooden kit version of the Conestoga wagon, but this gives me a really good understanding of the undercarriage of the entire wagon. And now I can physically see how this thing was built from its chassis all the way up. Valuable image to me. Other times, reference images give us a really great indication of the surface characteristics of the actual objects themselves. Is it metal? Is it wood? Is it concrete? Is it shiny? Is it all rusty and scratched up? The reference images are going to help us determine how this object is going to be modeled, but it's also going to tell us how this object is supposed to be rendered and drawn. Invaluable. Okay. So how do we work with these? Well, ideally what we want to try to find as much as we can are blueprints, engineering schematics, and I actually didn't have any engineering schematics on this one, But engineering schematics are going to allow us to see our little object here from orthographic viewports. Oops. This is some of when I say an engineering schematic, I'm talking about this. A line drawing that defines an anchor from a number of orthographic perspectives. It's an image completely devoid of any sort of vantage point, of any perspective warping or distortion in the image. From these line drawings, I can very quickly establish the overall shape and form. Now for your train, I'm going to give you an orthographic image that will help you define your model. Okay? We ultimately want to try to find blueprints or orthographic images that we can use in Modo. Best case scenario, we can use this as what's called a backdrop image inside of Modo. I've given you guys one for your train. It's included in the assignment sheet found on D2L. I would encourage you to download it. It's going to be required for this project. As a small refresher, what I'm talking about is this thing right there. Okay? The backdrop image. This is an image that we're physically going to import into our scene in Modo. So let's talk about how we can do that. Let's revisit Modo. I'm going to close this thing because it's killing my machine. Okay. In order for us to import an image into Modo, we initially have to create a container that this image is going to live within. This container is called a backdrop image. We can add a backdrop image very, very quickly inside of Modo. Check it out. If I travel into the upper right-hand portion of our interface, into what's called the item list, add item, we're going to go into this pull-down menu, and it's going to be the second item from the top, backdrop item. When we add this into our scene, you're going to see an empty white square. As a reminder, if it's way off in the distance, just hit the A key, and it'll become nice and big on your screen. Backdrop image. Go ahead and add this backdrop image into your scene. Create a new project file.
So does that backdrop image then go into the plane defined by the working plane? So if that working plane is different, then it would be...
Good question. No. In this case, no. In this case, no. It will automatically be placed at the origin of the scene, however.
At the XY plane.
On the XY plane. You got it. And I'll show you in a minute what controls that orientation. Backdrop item. Add item, backdrop item. There it is. Empty container, right? With our backdrop item selected in our item list, all of the properties for that backdrop item appear in the Properties tab below. And if you start to look at all these channels down here, we have a place where we can load an image, that image well. I want to click on this thing. I'm going to click on it, and you're going to be presented with what's called the clip browser, which is really just kind of an image library of assets that are already imported into Modo. Well, we haven't imported anything into Modo, so let's load it in real fast, okay? In the upper right-hand corner of your clip browser, we have a little pull-down menu. And from this, I'm going to choose Load Image. Not New Image, not New Image. Load Image. It's going to bring open your standard OS Finder window. You want to navigate on your computer to where you've saved that image. Oops, hold on a sec. Where did I save? Oh, did I move it? I might have moved it. Here it is. Nope, wait. There it is. All right, and ta-da! Once you hit OK, there's your train. Cool, huh? Cool. This backdrop image was made from the asset that was used to create the renders that you saw in the assignment sheet. So it's literally the exact same model. Let's return to our assignment sheet for one moment. So I want to bring to your attention an important requirement that I'm going to be asking you guys to meet. We're going to go through all these in detail here in a minute, but check out this one. Front of the train must be facing the positive z-axis. It's a requirement for this project. Let's jump back into Modo and look at what the computer has automatically done for us. Whenever we're working with backdrop imagery, we need to ensure that this backdrop image is placed correctly inside of our scene. Just kind of casually, what would you define as the front of our train? Where the grill is. I love it. Absolutely. So I think we probably could all agree that this is the front of our train. Right now, which direction inside of our three-dimensional scene is the front facing? I love it. Negative x. Mallory, help us out. How'd you come to that conclusion? I love it. So Mallory is checking out these little indicators on our grids, right? These guys over here. Positive x on that side. And if we zip around to the other side, there's negative x. I love it. Brilliant. Great job, Mallory. Perfect. What's another way that we can very quickly understand what direction our train is facing? You're right. Absolutely. You remember what that's called? The thing in the bottom left-hand corner, what's that called? Compass. The compass. The compass is always going to tell us the current orientation of all of our axes. Which direction do these little lines face? Positive. They face towards the positive side of that axis. So right now, if we look at it, the x is facing this way. The positive x is facing that way. So we can deduct that the opposite way is negative x, right? So right now our train is facing towards the negative x side of that axis. What side or where should the front be pointed according to the assignment sheet? Positive z. Positive z. Now, before you start rotating this bad boy, let's talk about a really cool thing associated with the work plane, or backdrop images, excuse me. The backdrop image, or the placement of the backdrop image within inside of our scene, is controlled by a couple different things. The guys down at Luxology are really smart, and they created a series of channels here that will allow us to work with these backdrop items very easily. The projection type is something that we need to draw focus to. This value determines the orientation of this image inside of our scene. In addition, it also allows us to see this image inside of the front orthographic viewport. So right now, I'm in perspective, but if I change it to front, check it out. What am I going to see? My train. Aha! If I change my scene to, or if I change my options to look at my scene through the top, what would you imagine I'm going to see? Nada. Okay? Nothing. It's invisible. If I look at my scene from the left, nada, nothing. Let me jump back over into perspective here for a minute. The projection type is always going to control which of my orthographic views this image is going to show up in. This is actually kind of a neat thing because I want to use this image as a tracing guide. If I change my projection type, check it out. The computer is automatically going to orientate this object where it needs to go. Now, take a guess. Take a guess. Which one of the projection types do you think we should change this to? Left. Let's try it. No. Let's try left or right. Right? Okay.
I think it could be wrong.
Could be wrong. Let's find out. Ah! So it rotated it. Now, which way is the front of our train facing? How do you know that? And you're right, but how do you know that? Compass. Okay? Look at the compass. The compass always directs us towards the positive direction of that axis. Compass is saying positive z is this way. My train is facing this way, so it's backwards. Now, before we go rotating it, let's take a step back for a second. Everyone just hit the pause button. When we changed the projection type from front to right, it gave us the ability to look at this image from the right view. There it is, okay? Ta-da! from this view, can you see that it's also facing it, that it's still facing the wrong way? Yeah, right? There's two things that tell us this thing is facing the wrong way. The compass is telling us this thing's facing the wrong way because positive z is this way. Our train is facing this way. We also get the positive and negative axis indicators at the borders of our grid. There's negative z over there. Our train is facing the wrong way. A lot of people, they instantly go, oh, I'll just rotate it so it's facing the wrong way. Nah, wrong. Don't need to do that. The guys down at Luxology are pretty smart. They know, that how to 3D model. They've done this once or twice before. So they've given us a really cool option found in our backdrop items properties called flip. Now, it's facing the right way. It's in your backdrop item properties. Flip. You very rarely, only in certain situations, truly need to rotate backdrop items. Changing the projection type and flipping the image often aligns the image to the grid the way we want it to go.
Just rotate on the y-axis?
We don't want to do that. We don't need to do that.
Why?
We don't need to do that because no, it doesn't make it easier though. We want to be able to view this image from the right perspective. Okay? If we rotated it, we're not going to see it, which is why we want to really rely upon that projection type and the flip command. Because I want to be able to go in very quickly. I just want to jump into my right view, okay? And I want to throw down some shapes pretty quickly, okay? From this, I can go in and just make some cylinders. I'll need some more resolution than that. I can go into my right, and now I can position that cylinder where I think it needs to go. I can also scale it down. And I can use this image to model to. This is not just a reference image to the overall form. It's going to allow me to, it's going to show me precisely where I need to place all these images, all these polygons.
We move the train up so it's like on the x-axis?
Again, are you reading my notes? Yes, absolutely, for sure. Now, the one thing that we need to do before we start modeling is ensure that this backdrop item is precisely where we want it inside of our scene. The foundation of our project file is going to give us good results if we do it correctly. Okay. Let me just get rid of this. If you look very carefully, the bottom of my image is arbitrarily way off down here at the bottom. I think it'd be great if all these little railroad tracks were up here towards the middle of the y-axis. That will make our lives a little bit easier. I like to have the middle of the y-axis kind of represent the ground in a lot of situations. Visually with the grid, it makes it easy to consume your scene and understand the spatial relationships between all these different parts and pieces. So I need to move my backdrop item up some, but it would also be really helpful if I could see through my backdrop image to the grid lines behind it. Right now, my backdrop image is completely obscuring the grid. I can't see it. Let's select our backdrop item and analyze the properties that are associated with it. Check it out. Backdrop item. Check it out. Look, we have a transparency value that we get to adjust. I want to increase this. I want to increase it to about 70%. It's going to make this image kind of ghosted. Hit the return key. There we go. And now I can see the grid lines behind the image. Step number 1 done. Step number 2, we got to move this thing. A backdrop item is classified as an item, which is the highest component type inside of our hierarchy that we can create and work with inside of Modo. It's not a polygon, it's not an edge, and it's not a vert. It's an item. So if I wanted to move this item, I have to be in item mode. We're going to spend a lot of time in the future talking about item mode, but it's right here in our selection sets. Check it out. Now I got a nice gold border around my train, and my move tool is active. And I simply can just move this thing where I would like it to be inside of my scene. And that's pretty cool. I'm happy with that.
Wait, say that again? Sorry.
So if I wanted to move my reference image Got to be in item mode because all backdrop items are items. They're not polygons. Once I'm in item mode, I can select it and just move it with the move tool. And I may even get a little nerdy here and get it precisely where I want it to go. Absolutely. So a backdrop item is classified as an item. So I need to be in item mode, and you can find the item mode selection set at the top of the screen, 2 down from your polygonal selection set button. Keyboard shortcut number 5 on your top row keyboard, by the way. Then, once you're in item mode, you can select it, fire off the move tool, and transform it to wherever you want in the scene. For me, I want all those little railroad ties just kind of chilling down here at the bottom of center of my y-axis. Okay. So if you want to increase the transparency of your backdrop item, just make sure it's selected in the item list. All the properties for that backdrop item are going to be displayed in your Properties tab, one of which is a transparency channel towards the bottom. Yeah?
My train is facing that way. How do I make it that?
Flip. One thing. I forgot to mention this. I noticed this on some of the screens earlier. If you're seeing these double arrows at the bottom of your screen, this is Modo telling you, hey, part of my interface is getting truncated and cut off. There's extra options that are flowing outside of the frame of my application. Just click on those double arrows. Okay, let's just check it out. Hold on a sec. So FYI, that's an application-wide kind of UI thing. If you ever see double arrows, that means there's more interface that's being, but it's being cut off. Yeah. Okay, Art, what you got?
So like, it's pointing that way, right?
Mm-hmm.
And if I
Perfect.
flip it, it points to the
Yeah.
negative
Okay.
Z.
We want to flip it.
I know, but that's positive Z is going that way, right?
Mm-hmm.
I'm confused.
Yeah, we want the train facing the positive Z that way.
Yeah.
So you had it right with it flipped.
Yeah, I know, but like,
Great.
I can't. How do I view it so the front of the train is pointing that way?
You can't.
You can't?
Well, the
So
only
why
other
is yours
way,
like that?
the only way to do that would be to change your projection type from left to right.
How do I do that? Right click?
Go back into your double arrows. See how your projection type's from left. I think mine's right. Now jump over into your right. Yeah.
Boom.
There it is. There it is.
Thanks.
Yep. Okay.
You want to make the tracks for the same as well, right?
Absolutely.
So we got copy paste.
Yep. We'll talk about that momentarily. Okay. Questions about what we've talked about so far? One final thing about backdrop items, then we'll move on to some really cool things. Now, when we're modeling here, we're often going to be having geometry at the exact same location inside of our scene as our backdrop item. It'd be great if I could see through my backdrop item in the perspective viewport. Right now, and same within when I'm looking at my scene from the right, okay? It would be great. I would love nothing more to be able to see through to the image in the back, because how can I understand the size of this thing when my polygons are kind of getting in the way? Here's how we fix it. It's a viewport property, so let's do this together. Put your cursor in the center of your viewport. Hit the O key. O is in October. It's going to bring open your viewport properties. Boop, there they are. Where we want to go is the Drawing and Control tab. And there's two things that we have to change. At the top, under the View and Shading category, we want to enable Overlay Drawing. The second thing that we have to do is travel kind of down towards the bottom of that exact same palette under the Background Imagery section and choose Overlay. Once those two things are turned on, check it out. Now I can see my image behind my geometry. And I can very quickly make some decisions.
Overlay drawing, what's the second one?
It's basically overlay and then overlay drawing. So you want to turn on overlay drawing at the top, and then you want to turn on overlay at the bottom.
If we save this file how we have it go to, say, a computer that normally has different settings, will it change to these settings when we load up the file?
They won't. They won't. So you have to change these on a new computer. Yeah, these settings are application specific, not project specific. With those overlay drawings enabled, you can also see that we're getting transparency in our perspective view as well. So allow us to use these backdrop images as tracing guides as we very quickly flesh out and build these shapes. So here's what I would suggest that you do. Save your project file. You've just done the initial setup for your homework right there and then, okay? If you notice on the assignment sheet, there's some specifics on how I would like you guys to name your stuff. There it is right there, last name GCOM 402, basic train. You've now just done the initial setup for your homework. If you look at the backdrop image, our blueprint, if you will, there are a lot of pieces on this train that are very similar to one another, right? The wheels are a great example. It would be a waste of our time to have to draw each one of those wheels separately, right? It would be great if I make one master wheel and then duplicate that over and over and over again, right? Modo has a really awesome duplication system. There's even a whole suite of tools that will allow us to duplicate our shapes along a number of crazy parameters. We're going to go over that in the future. I have an entire project dedicated towards the duplication tools. But for tonight, let's look at the duplication tools in its most simplest form. And believe it or not, it's copy-paste. It's copy-paste. This is another one of those things that I wish all 3D modeling applications had. Believe it or not, very few 3D applications have a true copy-paste function. The guys down at Modo have even given it and have even assigned it the exact same keyboard shortcuts. So, Control-C and Control-V, man. Absolutely. Let me just show you what I'm talking about here. I'm going to create, just quickly, the wheels of the train. Okay. There's a wheel. Now, spatially, this isn't correct. Whoops. Something kind of like that. Okay. But I need what? I need 4 of these bad boys. So instead of having to, they're all the exact same size. They're all the exact same size. So it would make sense to recycle this one asset over and over and over again. As with everything in Modo, we begin and end with a selection. Notice that I've selected polygons, okay? I have to do this in my polygonal selection set. It's not going to work in edges or verts. Well, actually, it is going to work in edges and verts, but you're just going to copy the verts, and we don't want that, okay? With my shape selected, I can simply go to the top of the screen where it says Edit, choose Copy. Keyboard shortcut Command-C, just like on Microsoft Word. Now, I'm going to copy those polygons, and then almost immediately after I'm done, I'm going to go back and choose Edit, Paste. Now, it looks like nothing's happened, but what we've done is we've copied those polygons back into their current location. Before you click and deselect, fire off the Move tool. And move back your second duplicated shape. Now I have 2. Oops. Yes?
And when I tried to go to the cylinder tool to start building something, it won't
Aha.
let me go there.
Yes, yes, yes. Okay. So, we talked about this for a second last week, but it's so important that we're going to talk about it again. Inside of Modo, the mesh item is the container for all of our polygons. Carissa, at some point tonight, and I'm not sure when, your mesh item got deleted. Without a mesh item, you can't draw any polygons. Help her out. How do we add a mesh item? Did any of you guys stumble upon it? Yeah, you got it. Add item. and it's right below, there it is, mesh. Once you have a new mesh item, you're on your way. So be careful. Be careful with when you're hitting that delete button, okay? Yeah, What's up? Okay.
So I made the first wheel. How do I?
You're still in item mode. Jump back into polygons, and now you'll be able to.
And then like all these things are applicable now.
Yep.
It's not a perfect circle.
Yeah.
I forgot how to do that.
So let's help Art out for a second here. How do we draw a perfect circle? You guys remember the sequence? Cylinder. Clicky click. Move your handle, your cursor away from the tool handle, some distance. Hold down the control key, and then left click and drag. You got it. All right. Let's spend a couple moments talking about what you're going to be expected to build on this first project. There are some details that I can't let you guys walk away tonight not understanding. Of course.
Shapes and stuff, is it possible to do them on like different layers?
There is. Yep. You could create a new mesh item. A mesh item in kind of conceptually works like layers. Yep. Yeah.
Wouldn't you use that for, say, you created a basic person as a character and then you're making like different interchangeable armors or something, you'd have those as a separate layer to base around?
You could. You certainly could. It's not a bad idea. Not a bad idea.
You think they do that in the professional realm?
I know they do that in the professional world. Yeah.
They do?
Yeah, absolutely.
Okay.
Yeah, working in layers is never a bad thing. I work in layers all the time. I think the important concept that you want to put behind layers is that you need, if it needs to be separated out, it goes on its own layer. Organizationally, have things on layers. On the rendering side, we can animate the visibility of our layers. On that big ship that I showed you guys a couple weeks ago, I have a whole bunch of layers because I animate the visibility of those things turning on and off at render time to make my render performance go up a little bit. So if I don't see it in the scene, I turn it off. And then when I rotate my camera around in the render view to when I see that element, I turn it back on. So there are a lot of advantages of having things on render or on different layers, for sure. We're going to talk a lot about items. I mean, a lot about items. This is I don't want to give you too much on our first kind of big model, but yeah. Okay, I've returned to the assignment sheet on D2L, and I just want to kind of walk through the expectations of this project because there are a number of elements that I'm going to be expecting you guys to meet over the next 7 days. You're going to be creating a 3D model for both the train, or so the locomotive, and the coal car. Here's the kind of the 10,000-yard description of this project. If it's in the blueprint, you're modeling it. So if it's in the picture, you're making it, okay? And that includes the railroads and all the railroad ties. Yeah. Yeah. The only way to be good at something is to do it 1,000 times. You're going to be copying. Then you're okay. Yeah. Then you're okay. Would it, oh, this is going to, me being me. I get a little crazy sometimes. I have fun with 3D. I do more in 3D than I probably should.
You probably modeled your kid already, right?
No, I'm going to scan him. Yeah. I went as far and railroaded, modeled the actual spikes themselves, which is kind of silly, but you're never going to see it in 1,000 years. Oh, man. I don't know about that, but...
That's the authenticity. You don't think about it, but then if you're walking around, you're like, something feels off.
You're going to, something like that you're going to see. You're going to see that. Okay, anyways, let's keep going. So the railroads and all the railroad ties, okay?
So we're just doing the basic 2 long rectangles parallel and then the bunch in the middle. We're not doing that little part? Okay.
I mean, if you want. I'm never going to say no. I'm never going to limit your creativity. I always set up the minimum expectations. If you want to plus it and just go super crazy on it, I'm going to go thumbs up. That's awesome. Okay? You're not going to get any more bonus points for it, but you know, you're going to get respect points from me. That's for sure. Okay? Yeah. Okay. So placement of the model must be in the center of the scene. Okay? I'm expecting you guys to center your object around the origin of the scene. Okay? Good 3D modelers work at the origin. I'm going to force you guys to do this, okay? This is one of those muscle memory things that you got. We're going to start on day one, okay? Muscle memory is such a pain in the rear to create, right? I hate going to the gym. I hate it. I hate it with a passion. I could find instantly 10 other things I'd rather be doing than sitting there on that damn bench doing this. Right? Wasting my time. It is, right? But we have to do it, right? We have to create the muscle. We have to create the memory. We have to tell our body how to perform so that when it comes time for me to heroically lift a car off of a child, I can do so.
You'll just be like, man.
Yeah, exactly. Exactly. Right. Yes?
Is it, when we press A, is that go to the origin, right?
It's going to auto-fit your scene. So if your objects are away from the origin, it's going to go to where your object is. If you've modeled something away from the origin of your scene, no biggie. We can move it pretty quickly. Let me illustrate this. So let me make a cylinder way off over here, clearly away from the origin. My origin is right there, right? I want that cylinder over there. Inside your basic tools, you can always do center selected, and that's going to move your object to the center of your scene. Let's just do all. Boop, and then it pops back. You also have a number of different kind of options here. You can center it along a single axis, combinations of two axes simultaneously, or just do all, and it pops it right back down to the middle.
So what happens if you have like two cylinders sitting next to each other and you did that? Does it move them all over or on top of each other? Or?
Good question. Good question. So if I had something like this, if I had both of them selected, they both move together.
If neither is selected and you do it?
If nothing's selected, what would you anticipate is going to happen if I chose center selected? Everything's going to move. Yeah, you got it. Since nothing's selected, everything's going to get changed.
Oh, so they're still not the same region.
How could I get them in the exact same spot?
You'd have to center one and then center the other.
There it is. Individually manipulate them. You got it. So I could go in, center selected all, then go back to this one, grab it, center selected all. Now you don't want to do this. That's bad because now we have geometry on top of each other. Overlapping geometry is bad. Yeah.
How do I merge meshes? Can you do that? Is that possible?
You can. This is one of the things I was trying to kind of avoid tonight was getting too much into how to work with different layers. Okay. I think the easiest way to merge meshes, Krev, here's your thing. Okay. Let me help you out. So let's pretend that I have two different layers. This one down here is this piece down there, and the other one is that one over there. So if I wanted to put both of these pieces of geometry on the exact same mesh item, believe it or not, our cut, copy, and paste tools will do the job for us. We worked with copy and paste. There's also my favorite, cut. So if I just do edit, cut from one mesh item, I can go to the other mesh item and then do edit, paste. And now I've kind of combined them.
Do you recommend we do this with just one mesh layer?
I do, yeah.
I have a question.
Okay.
You make different shapes and stuff as you overlap them. Does that mean if you technically just double click one of those polygons, they all mesh together, or since they're separate shapes, will you only click the one item?
You only collect that one.
Okay.
They're not welded together. So as an example of this, I have two separate cylinders chilling at the origin of my scene. They're crossed over each other. If I double clicked on one, it's only going to select that one.
Oh, awesome. Okay.
Yep.
I was concerned about that's why I wanted to do it separate layers because I ended up that one.
Yep. Yeah.
Can you help me get this cylinder like properly placed?
No, because there's no way to do it.
Oh, I have to
Restart it. Arthur has experienced one of the trials and tribulations of working in 3D. Nothing comes for free. It's not going to help you. You got to manage it. If you rotate it at an unknown axis, let's say you rotate it 10 degrees, you drop the tool, you walk away from it for a couple steps, then you want to rotate it back. Well, if you don't know which value you rotated that cube on, the computer's not going to know, and the computer's not going to auto-snap it back to the origin of the scene. So what's this? Unfortunately, the solution to this is rebuilding that shape. It'd be faster to rebuild it than it would to try to figure out the angles and make it look perfect.
Can you demonstrate that?
Sure. Here's a great example. If I look at my little object here, this crossbar has been rotated to some unknown angle. I don't know. I did that maybe 4 or 5 steps ago. I wasn't paying attention to the rotation values when I rotated it. There's nothing outside of just my eyeballs that will tell me which angle this thing is at.
Not even the stuff on the left, which is what X, Y, Z, that's the one.
It tells you what you're currently rotating it to, but I don't know if I need to rotate it 8 degrees, 9 degrees, 7.5 degrees. I don't know. I'm just using my eyeballs.
How do you make it snap without actually choosing the snapping option on the top right? I thought it was holding shift. But I think I'm wrong.
For the rotate command, if you hold the control key, it's going to snap to just 15-degree increments. You got it.
So you recommend this rather than eyeballing it?
I recommend paying attention to your rotation values.
So the stuff on the left?
Yes. Yeah, you gotta pay attention. The only way, the computer's not going to help you. The only help that you're going to get is that when you're initially rotating it tells you how much you're rotating it, but that value is going to disappear into the application once you hit the space bar. So if you don't mentally hang on to that rotation value in your brain or write it down, you're not going to know how to rotate this thing back to its original orientation.
So if you click off that and then click back, that 375,
Let's make it something really wacky.
it goes up, well, I mean,
392. So if I drop the tool and then come back to it, all those values are back to 0. Yeah. Yeah, we don't have tool history inside of Modo.
it doesn't even tell you what angle it's currently at.
Nope. So you got to manage it. You got to manage it.
901.
Yeah.
Sounds like a kid, I don't know, it sounds like a cat function or something.
Yeah, and it kind of is. It kind of is. Other applications have tool history where it kind of keeps track of the rotation that you've done for each little thing. There's only a couple apps out there that have that as a function. Everything else kind of works like this. Okay, let's go back to the assignment sheet real fast and just kind of round out the expectations for this project. As I mentioned a moment ago, I'm going to be looking to see if you placed your train and modeled your train at the center of our scene. Okay, that's an expectation that I'm expecting you guys to hit. The front of the train, model must resemble the shape and form of the backdrop image. So you're building the image that I gave you, okay? This is not a free-form jazz piece where you're doing your own interpretation of the model. You're making this train. To help you out, I've also given you a number of renders down here that describes the shape from some other different angles. So at the very least, you can kind of get a good sense and conceptualize how wide this train is going to be.
What's the underside though? That's one thing that's getting me is, are the wheels just kind of sitting like rollers, or
Yeah.
are they attached to like a cube?
There's a cylinder on the inside.
Well, I mean, between each wheel,
Yeah.
but I mean, to the main part.
There's nothing there, at this stage and at this resolution. There's nothing really connecting the wheels to the base of the train.
Okay, so
Yeah.
they're technically independent.
They are without a doubt independent. Yep. Okay. As mentioned earlier, the front of the train must be facing the positive z-axis. If you've been following along and working with this is done. Correct placement of the backdrop image at the origin of the scene. Again, this is something that was already done if you've been playing along with us tonight. Okay, one final thing. Starting tonight, I'm going to be holding you guys to the expectation that you know what you're doing.
Are you serious?
Yep.
Know what we're doing?
I know you guys know what you're doing. Well, at the very least, you know what you're doing with the information that's been given to you. Okay. I would like to make sure that you guys are paying attention to the edits that you perform on your mesh. I don't want to see any crossed vertices and edges and polygons, and let me show you what a crossed vert or an edge looks like. Usually they pop up when you start moving and rotating portions of your geometry. I've double-clicked that guy, and I'm rotating everything in there right now, right? But if I was to work with just a portion of this, let's say I was just working with some edges. Okay, and I did something like that. That's bad. We've crossed the edges. This is very, very bad form. It's bad modeling. It creates massive issues for us on the render side, and it ultimately creates a mesh that's uneditable. Okay? You've got to look at your mesh. You've got to look at your geometry. Be aware of how you're editing your shape, and be good stewards of your project file. Okay? The other thing that often gets people in trouble is when they start scaling things disproportionately. So if I was to select that face and scale it like this, or excuse me, let me turn on. That's bad. Okay? The moment you cross through it like that, that's bad. Okay? Let's go look how that rendered. Blackness. That's a render error. The computer fundamentally does not know how to draw that shape, so it just turns into a big black ball of goo. Okay? Please pay attention to your scenes. Okay. All right. And then, as always, as prescribed last week, you're going to be rendering everything in here at the resolution of 1280 by 720, and you're going to be saving to JPEG. Let me show you how to change the resolution and the frame size of your render. Last week, I gave you a project file, and all you needed to do is just to move things around and hit the render button. Done, right? This week, you're creating your own project file. So we need to change this one render setting. Let me show you where to do it. It's really super easy. At the conclusion of your project, you're going to go over to the Render tab. In the bottom right-hand corner of your interface, we have what's called the shader tree in this little shading tab. The shader tree is a list of all the elements that are influencing how the render engine is going to draw our image. The highest element in this hierarchy is that little purple sphere that says render next to it. I went to the Render tab. In the bottom right-hand corner of the interface, I navigated towards the shader tree. And I simply just clicked on that purple sphere. After you click it, all of the properties for your render are going to appear to the right in the Properties tab. The first vertical tab in this environment says Frame. And about halfway down, you can see a frame width and a frame height. Please change this to 1280 by 720, and you're ready to render. So 1280, 720.
How do I get there?
Yeah. So to get to this thing right here, just make sure you click on the purple sphere that says render.
Got it. Oh, I see it.
Yeah.
720 by
1280 by 720. 720p HD, that's the frame size that we're crafting here.
and it'll just save it, like I can close the program and I'm just reading.
This is part of your project file, so yes, that will absolutely be preserved in your LXO.
And by render, we just click the render button, right?
Yep. I heard another question. Krev, what was it? It's on the assignment sheet as well. Okay, these are numbers that I'm just pulling out of nowhere. I always tell you what size I want the final render to be at. Right there. 1280 by 720. In every sense, these, this is kind of like a little mini checklist for you guys, okay? These are the elements that you absolutely need to hit to achieve maximum points on this project. Okay. I've given you some additional reference images that will help you model this. At the conclusion of this assignment, as a reminder, you're submitting 2 things to the Dropbox. You're going to be submitting, of course, your LXL, your master Luxology project file, and then a JPEG of your train, a rendered JPEG of your train. Choo-choo! Questions on what we're striving to accomplish on our first model? Everyone's good, huh?
Yep.
Yeah.
Do you have like kind of like a tip how to do the windows and doorway on the thing, like perspective-wise, like what the size is, or just you want to like do our best?
Do your best. Do your best. Yeah. At times, your blueprints, your backdrop items are going to be lacking a certain dimension.
So, we have to do the windows?
Hold on. Hold on. Let me finish. It's rude to interrupt, okay? Let me just get it all out first, and then you can jump on me, okay? So you're going to have to do your best to figure out the dimensions that are not communicated in the backdrop item. It's a big challenge for us. It really is. It's a massive challenge. Sometimes we find reference images that tells us dimensions for everything from all angles. Other times we only get one. So you got to use that thing between your ears, okay? And figure it out. You're an artist, so you get to start doing something creative. Arthur. To answer your question, yes, you have to make an opening for a window. Think Legos, think additive. Yes, sir?
What were the 2 big gulps again where you're not supposed to?
Yeah, just make sure we don't want to cross any of the vertices. We don't want to cross the edges, okay? And historically, it looks like that, okay? Let me go back in time for a second here. Hit and undo. And really, what happens is when you start like scaling things like this, you go whoop. That's a bad one. Okay. Sometimes people work and they only have a couple edges here, and they'll scale it down. They'll do that. That's bad. We've crossed all the edges. Now they're going the opposite direction. Sometimes people rotate things oddly. We'll do that. Believe it or not, it seems kind of silly, but people have done this in the past. It happens. It happens sometimes when you don't even know that it's happening, okay? It's very, very easy to think that you're working and influencing on one side of your mesh, only to discover that you accidentally had another polygon selected, and it's transforming, rotating, and scaling both of them at the exact same time. Okay. Mm-hmm. And that's fine. And that's fine. That's called burying polygons. That's fine. Okay? Because those edges aren't crossed. See how I have 2 different cylinders intersecting each other? That's fine. That's fine. What we're trying to avoid are ugly renders, okay? And render errors that are generated from when we do this, Nathan. Okay? We don't want that. We don't want that. Okay? If you're very mindful, it won't be a problem. This issue is going to become more important in the future when we start adding a new level of editing tools into the mix. Other questions?
How did we put that working axis onto something again?
You're not going to require to do that for this.
But just out of
Yeah.
curiosity.
You can just make sure you have something selected, the element that you want your work plane to be moved towards. I shouldn't even shown you guys this. I know. So that polygon's off axis. So I got it selected. If I go to work plane, align work plane to selection. Okay. Now I can center things. Now the buyer beware, okay? This is going to completely change your modeling, kind of interface. at the conclusion of whatever it is that you're doing, you have to go up and reset the work plane, okay? Because all of your views are now different. If you don't reset it, that's not the left part of my scene. That's not. You know, the top, that's not the top of my scene, okay? The moment I reset my work plane, that's the top. So you got to make sure you go back into that work plane menu and choose Reset Work Plane. Oh, someone asked me this earlier, and it's a good little keyboard shortcut. I'll end the night with a power user keyboard shortcut. You're going to find yourself over the next week or so jumping in and out and around your scene using that button at the top left-hand corner, right? To see our train from the top, go up here to the top, you know, want to see your train from the front, you know, so on and so forth, okay? Great trick that I use a lot, actually, is a little pie menu. If you hold down the Control and Space bar, you're going to get what's called the hot box, okay? Pie menu. And now I can put my cursor over any one of these predefined viewports and just let go of the keys and it will pop into that. So there's perspective, and just got to let go of your keyboard, Control Space bar. There's your front, there's your left, there's your top. A great way to very quickly jump around your scene to these predefined elements. Hit me.
Can you help me make the center thingy?
The center thingy. Cylinder, right?
Yeah, but last time I tried to screw it up.
Okay, try again. Any other questions? And then I'll give you a hand. Okay, we've got about 20 minutes left in class. Let's use this time wisely, okay? You can get a jump start, or we got about 15 minutes left in class. You know, use this time wisely, get a jump start in your homework. And otherwise, we'll see you next week.